Alright, so these slides are from CS 230 of Stanford and they were prepared by deeplearning.ai. So we were doing object detection, we had completed the sliding window algorithm part, okay. Now, okay. So now what was the problem with sliding window protocol? We have talked about it here. What was the problem with sliding window protocol? Computational cost. So if you want to cover every object, right? So, and if you have mismatching objects, this will be a huge problem. If you want to classify truck versus tennis ball, you will be using same window size, right? So maybe truck will come only, let's say, in 4 or 8 sliding windows, that ball will appear into so many of them, right, because my window size is large. One thing. Second is, even though this is fine, you may still not get a accurate bounding box. Why so? And basically both problems are related. So what is happening in this case? None of your, if you look at this particular thing, none of your sliding windows is actually capturing the complete car, right? And this situation can occur, right? Because you won't be taking a stride of 1 for sure. If you are given an image of size 1024 cross 1024, you won't be taking a stride of 1, you will most likely take bigger strides, much bigger one. So you might have an object that does not get a proper bounding box, as you see here. So let's say if this was the window size, right, then you take a stride and you go here, you take a stride and you go here, you take a stride and you go here. You keep on doing this, none of these. So I have one window, I have one window is this one, another window is maybe this one, right? No. Another window is maybe this one. And none of these is actually capturing the car perfectly, right? So how do we do that now? So with this we start the YOLO algorithm. And YOLO, with all the improvements that they have done over last 10 years, is the state of the art object detection algorithm, okay? So recent YOLO version is version 12. Now these YOLO papers are pre-transformers era. YOLO version 12 actually uses attention mechanisms to do things, but we are not there yet, so we will not talk about any of this. We will simply talk about YOLO until version 3, okay? So tell me, how is it doing? Will you have sliding windows? Sliding windows, are you having sliding windows? How does this slide help you? Did I switch on the recording? Yes, I did. Yes. Yes. So let me help you. How does this help you? Yes. Yes. So you have here. So original image is of size 10 cross 10, sorry, 100 cross 100. You divide it into 3 cross 3, right? So total 9 parts. And how did you get this 3 cross 3 cross 8? What is this number 8? What is this 8? Depth, of course, depth, but how, why 8? No. 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 Huh? But why? Why did you make this choice? But this is your target output. That means this is your ground truth. This is your label. So there you don't play things. So 8, we have done this before. 1 was for PC, then 4 for my bounding box, and 3 were my classes. They were, what were the classes? Pedestrian, car and motorcycle. Okay. So 8, now what will be there instead of this 8 if I have 10 classes plus background? Yes. Yes, yes, yes. So this is 100 cross 100. We change it to 3 cross 3 cross 8. Why 8 here? 1, 4 and 3. Okay. Now, if I have 10 classes plus 1 background, what will be the size of this last one? Yes. See, this 1 will just come here and then 4 bounding boxes, 5 plus 10 classes. So that will be how much? 15. Okay, and so on. So this is what we have. Why 3 cross 3? So 3 cross 3 and why 3 cross 3? That's my question. Kashish, why 3 cross 3? Our choice. Okay. So you wanted to break down this particular figure into 3 cross 3. If you wanted to break down this in 4 cross 4, you will have 4 cross 4 here. If you wanted to break down this in 10 cross 10, you will have 10 cross 10 here. Okay. So that's where our choice comes into. This also is relevant to our choice because this is how we have chosen to represent our each vector. Okay. So as you see now, this is, you can eat without any problems. Okay. So eating is fine. Now 3 cross 3 cross 8. Okay. So 3 cross 3, you decide. Okay, how are you going to break this image? दोस्त गेट नहीं खुल रहा है. So 3 cross 3 cross 8 is fine. Now as you see, things have started becoming much more difficult. What was there in classification? What was there in classification? Classification, how were you preparing the target output? So if my image has cat and let's say cat is class here, or let me just use the example that we have running here. So I have 4 classes. If I have car, this is what it is, right? So if I have 4 classes, this is how I was doing. This was my y. If you see here now, this is my y for this image. So I am trying to emphasize it here. This is my input x, this is my target output y, this is my label y. So until now we were having issues only in training. Now we have issues even in labeling them. You see, my every label is such a heavy one. Earlier it was just saying whether there is a car. So how can you prepare this one? You have 1000 classes. You prepare a training set folder. In that one folder you have 1000 folders. Okay? And each one having its own class. That was much more easier to implement, this guy. But in this case, what are you supposed to do? See how much work you are supposed to do every image. So let's start from 0 again. This is my image. How many classes do I have? 4 of them. They were pedestrian, car, motorcycle and background. Okay, so they are here. My target output will be 3 cross 3 cross 8, and this 8 is precisely coming because I have 3 classes plus 1 background. So this is what you have. Now what does this vector mean? If there are
no object, like no object which belongs to the class,
right. So if you don't have an object that belongs to pedestrian or car or motorcycle, right? If you don't have this, then basically you don't have any object in this image, and whatever is here does not make sense. So of course there will be numbers here, but those numbers don't matter, right? What about this one? So explain me the difference between these. Message कर दो ग्रुप पे. Yes. So why these 4 vectors? What is there in the first one? First one actually is giving you the whole structure. So this is PC. PC is for what is the probability that there is a class in this, right? So this is a binary classification problem. Either there is one of those three classes or there is not. So this is that part. This is giving you bounding box. This is giving you the class in this one, right? So tell me, if you have this as the target output, how many objects will you detect? What is the maximum number of objects you will be able to detect if this is your input image and this is your target output? How many classes can you detect if this is your input and this is your output? You were right, 9, right? Okay, object. So this one will give me 1 cross 1 cross 8. In those 1 cross 1 cross 8, so that 1 cross 1 cross 8 will look like this. So tell me, what will be PC here? What will be PC here? It has to be close to 0, right? Because there is no object here. What will be PC for this guy? PC, PC, 1, PC and 0. So if you will see, most of the times you will see PC equal to 0 unless it's a very crowded thing or unless you have number of classes is huge. So if you have huge number of classes, if you have very high number of classes, then these guys will have PCs close to 1, else you will have PCs close to 0. So if I bring now, trees, sky, traffic lights, signboards, road, marks on the road, if I include all these as objects, then almost everything will have PC equal to 1, because everything that can occur, I am keeping it in mind the number of classes. Any questions here? I want you to perfectly understand the relationship between this and this guy. And right now there is no training going on, we are just trying to understand how will I prepare my training data set. Okay? So is this fine? Okay. PC is 0. Now what does this represent? So the probability of object is 1. Here are the bounding boxes. So now they make sense, right? They cannot be question marks anymore. And the object is car. Similarly, what about this yellow one? If you see here, green one belongs to this part and yellow one belongs to this part. In both of them we have detected a car. Any questions here? We have not done anything technical right now. All we are doing is, there is this input image and then there is output corresponding to it. We are just trying to understand what is the output corresponding to it. That's it. ठीक है, चलो. So you started from 100 cross 100 cross 3 and your output is 3 cross 3 cross 8. This is your input, this is your output. How do you connect input to output? Through your neural network. Okay? And in this case it is a CNN. So tell me, how will you do it? Now what YOLO does it, at least until this version, it does not break into 3 cross 3. It breaks into 19 cross 19 and cross 8 will remain the same. So this image will not be broken into 3 cross 3. It will be broken into 19 cross 19. Okay. Why 19 cross 19? Your choice. Okay. So coming back to this, specify the bounding boxes. So no, I won't go here, let us spend a lot of time here. So how do I prepare my training data set now? Who will do it? So you have total 361 grids, right? 19 cross 19 will give you 19 cross 19, total 361 grids. So how will you prepare this training data set now? How will you prepare this output? Who will do it for you? For everything, what will be your label? What will be your label for this guy? कर पानी चाहिए भाई. 0. If the first element is 0, do I care about the rest? No. Okay, so this labeling was easy. What about this one? 1. And then of which class? Car. So I will have 1 here. And what about bx, by, bh, bw? Somebody will have to give me this bounding box. Who will do it for us? You will need to have a human labeler, right? And now that's why you see classification was an easier problem comparatively, but this is a very hard problem because for every image you are supposed to do so much manual work in this. For classification, all you were supposed to do was drag an image to a folder of that class, right? Which is a much easier thing compared to going to every image, putting a bounding box around it, then putting it inside a folder where that particular class is. And now there are problems because you can't put this whole image into a particular folder because you can have pedestrian here, you can have car here, so problem has become much more complicated. How many of you see this complexity? So that's what we are saying. Instead of 3 cross 3 cross, we take 19 cross 19. So YOLO paper, at least in those days, authors decided that 3 cross 3 is giving you too big sub pictures, so take 19 cross 19. Yes. So finally what they have done is we go to pixel level. We go and classify every pixel. So the way you will do it today is this pixel belongs to sky, this pixel belongs to sky. Now next you see this pixel, it belongs to tree, this pixel it belongs to, so there are so many pixels that belong to traffic light. So for you are doing things pixel wise now. Huh? Now you don't need to do things manually, not that much. No, so that's a good one. You are just putting this into grid. So if I were to put this one, right? None of these grids are actually capturing any car, and we'll see how does this work. Okay, so what YOLO does is it does not depend whether one grid captures an object fully or not. No, it's a complicated one, we'll see. So instead of 3 cross 3, you divide it into 19 cross 19. I'll remove this, I'll keep it 3 cross 3 right now. Okay. So is this part clear? How do you prepare your training data set? Until now we were just struggling with how to prepare your model. Now just preparing a training data set, you see how much work is there just for one image. For millions of images, this will be a huge amount of work, and you can't really get it done unless you involve the crowd or you pay heavily. So like OpenAI has spent millions on paying human beings for RLHF thing. Okay. Now specify the bounding boxes. So this is my grid, but my grid is not same as my bounding box. So this is one very important deviation from sliding window. In sliding window, my grid that I was moving was my bounding box. Now this is my grid and my bounding box is different. Okay. And this is my grid, my bounding box is this one. So how do I specify bounding box now? So my y is same 1, then bounding box, then classes, class is car, 0.4, 0.3, 0.9, 0.5. Okay, specify the bounding boxes. So how do I specify a bounding box? Yeah, that's a problem now. How do I specify a bounding box? Like, so if this is 0, 0, so let's say this becomes whatever 4, 3, and then height is let's say 3 and width is let's say 4. Let's say this. Okay, but then you will have the same number exactly here as well. So you can't really have one marking for everyone. You keep 0, 0 here and then specify bounding boxes. So is that fine? So you keep one reference for the whole image and not reference the grid wise, because that will create problems. You will have these numbers same for all these guys, their relative location in the image will not be specified. Is this fine? यार एक तो ये थोड़ा सा इन्वॉल्व टॉपिक है और ये सेकेंड आर वाली क्लास है. यस, bounding box. So if you have, let's talk it this way. Let's say Facebook is paying you $20 per hour, okay, and you are making bounding boxes like this. They will eventually either not hire you or will start paying you $5 per hour. So since you want to earn more, you don't want to go from $20 to $5, you maybe want to go from 20 to 25, so you will be precise in giving your bounding boxes. So you want to be a good labeler. Of course, you will have good labelers and not so good labelers, right? So, and all these things will creep in your data, but that you have to live with. More questions here. So if you have two cars here in the same box, in the same grid, we have a problem, because this is just only one bounding box. So my algorithm will recognize only one object until now. We'll later see how to improve it, but right now it will give me only one bounding box. That means it will give me just one object. It can be car, it can be pedestrian, it can be another car, it can be two cars here and one pedestrian. It is still going to give me just one car. So that's why they go from 3 cross 3 to 19 cross 19, because then the probability that the same grid will have two objects actually reduces, and that probability becomes 0 once you go to pixel level. Once you go to pixel level, that pixel will belong to only one class and nothing else. Okay? More questions here. No. So this pixel, for example, belongs to street light. So there will be multiple pixels belonging to street lights. So each pixel will belong to a class, this one. So that pixel is not specifying what it is. That pixel is belonging to something. More questions?
You need to know the scale of it. If I were to put the bounding box or the kind of outline.
So simple. I have one image. This is my 0, 0, and everywhere else, for example, if you have this bounding box, so whatever this is, okay, so this becomes my bx and by, and then I have my width and my height of the bounding box. This is 4, 3. I randomly chose a scale. This is 4, 3. This 100 cross 100. This 100 cross 100. So whenever we talk about images, 100 cross 100 would specify 100 pixels this direction, 100 pixels this direction. This 4, 3 has nothing to do with pixels as such. So that was a wrong way to do. You should do whatever this particular. But you can measure this even in centimeters, for example. Right. More questions here. So either I am being too slow. How many of you vote for too slow? And how many of you too fast? That nobody does. So fine. Is this preparation of training data fine? Because YOLO में एक यही चीज main है. Rest of you fill in with convolutional layers that you already know. Okay. So we go next. So now we talk about IOU. So evaluating object localization. We have seen that, what we have seen? We have seen that I can have a situation in which no sliding window captures the object perfectly. We can have a same situation here. Remember, I had drawn this. We can have a same situation here where no one grid captures the object perfectly. So I will again do this. So let's say if grids were small, then none of these grids is actually capturing the object perfectly. So this is my bounding box, but none of the grids is capturing. Now this is a super important distinction between sliding window and YOLO. In YOLO, you have fixed these grids, and all you are saying is this grid will have an object. In sliding window, you are making your sliding window such that eventually you hope that this sliding window will fully capture an object. Okay? In this case, none of my grids are capturing this object fully. So how do we solve this problem now? So I have my grids like this, but I have my bounding box like this. Okay, this is an important thing. We'll talk about this now. So intersection over union. Evaluating object localization. So you have this purple one, you have this red one. You have these two bounding boxes. So intersection over union, IOU simply gives you the size of yellow one. What is yellow? Yellow is the intersection of these two bounding boxes. Okay? So intersection over union. What is intersection? The yellow part. What is union? The purple and red. Okay, so union of this gives you this, whatever it is. Now, in which case will this be 0? When these two bounding boxes are not intersecting at all, and in which case it will be 1? When they are basically the same. Okay. So more generally, IOU is a measure of the overlap between two bounding boxes. And why will we need this? So you have multiple human labelers. Okay. You have multiple human labelers. Oops. You have multiple human labelers. One gives you this bounding box, another one gives you this bounding box for the same object, because the same image you have given to multiple human labelers. So you will, each of them will come up with different bounding boxes. Okay, so you need to take care of which bounding box is the right one. So whether it signifies the same object or not. Okay, so you have these two bounding boxes. More generally, IOU is a measure of overlap between two bounding boxes. So where are we going to use it? यार ये 2 घंटे वाली क्लास का कुछ करना पड़ेगा भाई. हाँ, क्या करना है बताओ, कौन सा सुटेबल टाइम दूसरा बताओ मेरे को. अच्छा, so then let's continue with this. Yes. Why do you need IOU? So you will get two different bounding boxes for the same one. And what do you need to decide? You need to decide whether these bounding boxes capture different objects or is it the same object. Okay. So now,
Sir, if the human labels already like defined these boxes and all, bounding, why we need to do all this?
sorry.
If human labels already bounded subject, they only did all, they done it manually and done the object and all things. Why we need to do all this?
वापिस देखो, this is your car.
I understand that.
One human labeler puts the red one, another human labeler puts the purple one. Okay, which one actually captures the car?
I understand that.
Sorry, not this one. Which one actually captures the car? The question here is, are both these bounding boxes capturing the same object? They are. Both these bounding boxes are capturing the same object, but they are different bounding boxes. As an algorithm, how do I know whether they both are capturing the same object or different objects? Okay? More questions here, bhai? Or else we'll be done with YOLO. So non-max suppression algorithm now. This is where we will use it. So non-max suppression example. But I don't want to do with this physics. So I think that's enough for today. So we'll start with non-max suppression because then we are done with YOLO. That's it. And this is what we'll do in the next class. हाँ बताओ. Right. See, you can't do better than the human labelers that you have, right? So if one human labeler gives you this bounding box and let's say another gives you this one, you have to live with it. It's a wishful thinking to say, oh, everybody should have given me the same bounding box. This won't happen. So further, algorithm जो सबसे no, we are not fixing the right bounding box. What we are saying, I have two bounding boxes for this car, purple one and red one, right? My question is just this, are these two different objects or the same object? So in which case do you say they are the same? When IOU is greater than 0.5, you say they both are basically marking the same object. Okay? More questions here.
We are using this only to say that they are same object, right?
Yes.
Then nothing more.
We will use IO in non-max suppression, where what will happen? So let me just get into this once. You have 19 cross 19 grid. So how many bounding boxes will you get in this case? What is that number? 361, right? You will get 361 bounding boxes. How many objects do you actually have? 2. So for 2 objects you are getting 361 bounding boxes. A lot of them will have PC equal to 0. So that's a good thing for us. If you look at this part, they are both detecting a car. That means PC will be equal to 1 for both of them. So these 3 grids, right? So let's say if there is a human labeler who gives this one, its center will be BX, BY will be, let's say, here. There is another human labeler who puts this labeling box. Is this okay? Fine. This is not that bad a bounding box. But let's say BX, BY comes here. I have 2 grids detecting the same car, right? What should I output? And similarly for this guy as well. So something like this, let's say. And bounding box was this one. Okay, now this is, and let's say this bounding box. So I have 3 grid cells claiming an object of type car, but it is the same car. Okay, so you use IOU in non-max suppression to deal with this. That we'll do in the next class, and similarly for the other cars as well. More questions here? All right, then that's it for today.